All right, so let's try to approach this. So maybe I can have you help me talk through it. If I'm worried about safety, what's the operation here to look at that could potentially write past the end? The mem copy. Yeah, okay. So what do I need to check to figure out whether that mem copy is safe? Uh-huh. Yeah, okay. It's going to write len many characters, so let's make sure the buffer has enough space for that. How much space does the buff have available for it? Someone give me a reason why you might argue this is safe. Yeah?
Well, the buffer has len plus 2 space, so you could never have, you could never fill it up because there's always going to be that extra space if you're only going up to len.
Okay, so tempting to say there's len plus 2 space in there, so we're going to write len with the mem copy and then 2 more for the other ones, so we're never going to get past the end. Someone give me a reason why it might not be safe. Yeah, in the blue, yeah. Yeah, okay, so if len is too big, then len plus 2 will overflow, wrap around. Give me an example value of len that could cause a problem. Yeah?
1 minus the largest integer value.
Yeah, like the largest possible integer value minus 1. Or the largest possible integer value also would be a fine answer. Because if you add 2, it's going to go beyond the largest possible. So let's say we're on a 32-bit system. So size underscore t is a 32-bit unsigned int. So the largest possible value is 2 to the 32 minus 1. If that's what you passed in as your len, when you add 1, you might think you get 2 to the 32 plus 1, but you don't, because there's only 32 bits available. So all arithmetic is implicitly modulo 2 to the 32. The higher bits get discarded. So that wraps around, and after the modulo, it becomes just 1. So you've only allocated 1 byte, and then the mem copy starts writing 2 to the 32 minus 1 bytes. Okay? So it's not safe for this very specific value of len. There's 2 values of len where it's a problem. All the others is fine, but these 2 values of len cause a problem. They cause a wraparound, integer overflow. Okay, so this is known as an integer overflow bug. And when you're doing calculations of lengths, you have to be careful about integer overflow because integers in C don't work like mathematical integers, unbounded numbers. They wrap around. Okay, so this code is not safe. Everyone who said not safe, spot on. And I thought I'd share with you a fun example that I ran into in my own work. I told you I like to work on electronic voting. Well, here was an article from 2004 in Florida. Oh, poor Florida. They just have so many voting problems. I feel so bad for their election officials. And this is kind of a fun story where they were embarrassed because the numbers that were initially coming out weren't quite right. And I want to highlight part here. The numbers were wrong. And someone observing on election night complained because they noticed the number of votes for their candidate started going down at a certain point in the night. And here's the explanation from the election official. The poor election official is not a computer scientist who had to have this, some developer was trying to explain what's going on, and she has to, I guess that's the mayor, has to explain to the public about what's going on. You're a computer scientist. Give me the computer science explanation of what was the bug in the code. Okay, of the kinds of flaws we've talked about so far, which flaw was this in the code? Integer overflow. Walk me through where you think that vote count, that number of votes was stored in some kind of a variable. What do you think it was declared? Like what kind of thing? Like a 16-bit integer? 32,000 is a very suspicious number. Should be a very suspicious number to you because it's close to a power of 2. It's close to 2 to the 15, 32,768. It's 2 to the 15. So what does that tell you? This was probably stored in a 16-bit integer. And what kind of integer? Signed, unsigned? Signed. And what happens if you get to 32,767 stored in a signed integer and you add 1 to it? It becomes negative 32,768. And then you add 1 to that, what does it become? Negative 32,767. And then negative 32,766 and negative 32,765. And if now you imagine some way that the printing left out that negative or someone didn't see the negative sign, what it looks like is each time it's incremented, the number looks like it's going down. So you get exactly this behavior. So what were the mistakes they made? What mistake did they make? Oh, come on! 32-bit. They should have used a 32-bit int. Why? Yeah? Mistake number 1, they were using signed integers because number of votes should never be negative. Mistake number 2, change that signed int to an unsigned int and they're good to go? They're golden? Bigger int, yeah, so 16-bit wasn't big enough, and it's kind of crazy to have that limit in the number of votes you can handle.